where irrational numbers come from is from right here. If we have the square root of negative 50. Okay, everyone take out your calculator and type in the square root of negative 50 and tell me what you get back. Should say error, right? The reason being why it says error is because calculators can't compute complex numbers. So, the way we're going to do this is we're going to factor this. We're going to factor it the exact same. The only difference is now we have a negative underneath the root. Anytime you square root a negative number, an I comes out. So square rooting a negative number, an I will come out. The square root of negative 1 would be just I. So square rooting a negative number, I comes out. And then, now what does the I represent? It's a complex number, right? Which is 25 and 2, 5 and 5. Once again, we're going to have a pair of 5s. So our solution to the square root of negative 50 is 5I square root of 2. Simplified. Okay? So, if I have another one like the square root of negative 72, if you have the square root of a negative, I comes out, and it becomes a positive inside of the root, which is going to give us 36 and 2, 18 and 2, 9 and 2, 3 and 3, which is going to give us a pair of 3s and a pair of 2s. So on the outside, we're going to have 6I with a square root of 2 left over. 3 times 2. That's the square root of a negative is I. Where do I get what? Look, underneath our root, we're going to have I square root of 3 times 3 times 2 times 2 times 2, right? Pair of 3s and a pair of 2s, we bring 1 3 out, 1 2 out, which makes 6 I square root of 2. You guys should have learned about, you guys remember this. Okay? Alright, another. So here, try this one on your own. The square root of a negative 120. Factor it. I mean, not factor it. Simplify it. Go. Okay, so here we go. First thing is I'm going to pull out an I. The square root of a negative is I, which is going to leave us I squared of 120, which is going to give us 60 and 2, 30 and 2, 15 and 2, 5 and 3. So if you want to write it all out, which I didn't think I had to, but I guess I do, we got to go 5, 3, 2, 2, and 2. We have one pair of 2s, so we can bring out one of them. So now we have 2I square root of 5 times 3 times 2, or 2I square root of 30. Okay, who got it right? Good. Okay, right here. If there's a pair, you bring out one of the numbers. They stay underneath. 5 times 3 times 2 is 30. Okay? Hey, this is something we spent 2 months on as freshmen. So the I is just as negative. The square root of a negative makes I. Kinley? Hey, go.
Why do you have to do all this stuff? Why don't you just decide it's 30?
Well, you can't just decide it's 30. You have to know what the roots are to be able to tell if it's 30. You have to do all this to get all your roots. Because the number can be great big. We could have the square root of negative 1024, which is going to give us I squared of, shut up, Dan. Dan. Turn around. Face the wall. The whole desk. Hurry up. So we could do it like this. So even if it was something big like 1024, you still have to factor it. Look at this one. You guys like how I picked out this one? I know it's stupid. Here you go. I always do. Now there's a reason for that. Yeah, if you do it like that, if it's ever an even number, I always do it 2. Because it allows for you to see it better and allows for you to simplify it quicker. If you start doing things like you could have done like 3 right here and it would have went into it, but it would have been a nasty little number, right? Oh no, it wouldn't have. 2 to 3 doesn't go into it. But you could have done like, I don't know, 110 and 30 or whatever it is, and it would just, and then you'd have had 2 different branches going down. I don't like having 2 branches coming down. So if you do 2 great big numbers at the very start, then you get it. But look at this one. So now we're going to have I square root 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh my goodness, this one comes. Yeah, I do it at the very. I don't put it underneath the root. Which, if you guys would have been here, I just go right here to get my 2's. Look at that. That's a perfect square. Did you guys know that? Well, just to show you. 2, 4, 2 times 2 times 2 times 2 times 2. I think it's 32i would be your answer.
Yes, I can trade.
If you want, but it's never going to come out whole for you today. 4, 8, 16, 32. Done. Okay. Next thing. So that's the first thing is just where I comes from. I comes from square root of a negative. Okay. That's where it comes from. So the first thing you're going to be asked to do is to be able to, I guess, simplify square roots. The second and last thing we're going to do today, so section, like I told you, section 3.2 is long. It's long. It has 5 different parts. We're going to cover 2 of them today. The second thing is this. I want these written down inside your journal. I to the 1 equals I. I squared equals negative 1. I cubed equals negative I. I to the 4th equals 1. Okay? And it repeats itself. It goes on repeat. So if I had, you don't need to write this, but I to the 5th, it would equal I. I to the 6th equals negative 1. I to the 7th equals negative I. I to the 8th equals 1, and so on and so forth. It continually repeats itself over those 4 different things. Which allows us to say something. If we had I to the 23rd, okay, I to the 23rd, now we could count out and keep going, or I'm going to show you the way that you should do it. So, what?
Why is it negative 1 and 1?
So complex numbers has its own number system. And I'm not going to dive more in depth because in Math 3 you dive a ton in depth in it. But it has its own individual number system. So I times I gives us actually negative 1. And the whole reason you got to remember back is that it's all underneath the square root.
Okay, so...
Wait. Is that I negative 1?
So, where are you looking, Liv?
Are those negative exponents?
Nope, these are all positive exponents right now. Okay? So what I'm doing is I'm teaching you very basically just simplified, and then we're going to get more and more in depth as the weeks go on. So I to the 23rd would actually be negative I. The way we do this is what we're going to do is we're going to divide 23 by 4. which is going to give us 5.75. Now I'm going to show you a little shortcut here. Okay? So, Dan, go. Call now. Go. Go out and have a mass break by yourself. Go. Hurry. Yeah, go. Okay. So, 5.75. So, no matter what the exponent number is, we're going to divide it by 4. The remainder will tell us where we're at because it repeats itself. Now, this is something you guys could write down. If the remainder is 0.25, it's going to be I. If the remainder is 0.5, it's going to be -1. If the remainder is 0.75, it's going to be -I. And if there is no remainder, meaning it goes into a hole, it's 1. So you could always just divide the exponent by 4, and the remainder will tell us what the digit would be. So this one is 5.75, so because it's 0.75, I know I to the 23rd would be -I. Okay, if I have I to the 71st, I could divide that by 4 and I get, that's 0.75 again, right?
What does it also say?
So,
71st.
that would just be I, wouldn't it?
So this would know. So I to the 71st gives us a 0.75, which is -I again. I to the 57th gives us a remainder of 0.25, which is I.
So why 4?
Because there's 4 different possibilities. See this? And it repeats itself every 4th one. So it goes from I to -1 to -I to 1. And then it repeats itself. I to -1 to -I, then 1. And then it repeats itself again. So it has 4 different possibilities. That's why you divide it by 4. So this one would be if it goes in evenly. So if it goes in evenly. So like if you had I to the 40th, that would be 1. Because it goes in evenly. Yep, if it doesn't have a decimal, it's just 1. So we could write that, no decimal.
Can't you also figure if it's a multiple of 2, but not 4, it's -1, and if it's a multiple of
No, now you're getting too far into it because it does switch later on. Huh? Okay, so any questions on this part of I? If it's an even number, it's either, but 2 and 4 almost go into the same numbers. It's easier just to divide it by 4 in your calculator and tell me what the decimal is.
Yeah, that's easier, but couldn't that also be a way if you don't have a calculator?
Yeah, it'd just
So
be a
if it
little bit
goes into
tougher.
4, it's 1, but if it doesn't go into 4, it's negative.
-1, yeah, only if it's even.
Yeah, that's
So, okay. Any questions on those two things? So today's very basic. Today we basically told you where I comes from, and these are like the fundamental principles of I. Simplifying the power of I. Tomorrow we're going to learn how to add I, and we're going to learn how to multiply I. And believe it or not, and then